Right, everybody. Again, welcome for thanks for coming to the Q&A session. I just checked the Google Doc for the questions. I don't see anything related to week 3 yet. So you can ask me maybe during the Q&A, and then it could be that you are following quite well, so maybe you don't have any question. That's okay. The only question I saw on the Google Doc is actually some question from week number 2 about shallow copy. How about I talk about it quickly first, and then we got still a very good number of you. I got 20, 21 people there. I really appreciate you coming. So you can still ask me questions maybe after I finish the first question on the Google Doc. Okay, let's do that. Okay. All right, so let me talk about that question specifically. This is basically something you did from the previous week, just about shallow copy. Okay, so okay, I'm pretty sure I'm sharing my screen. Okay, so good. So now this question here is like this. So basically, your fellow student was a little bit confused about what's the limitation for shallow copy. So that's a confusion. Let me try to explain that because they somehow put this example here. Remember when we first talk about shallow copy, right? We actually use this array example. We got OIMP. Let me just circle that. We got OIMP and also we got IMP. And that's a first example. And then we talk about either first level change by just reassigning the objects, or we can do second level change with simply append a string object over here. So that's the example number 1. And somehow your colleague compared this with this particular example when we talk about writing complete postcondition. So it's basically a very similar layout. So now rather than having simply string objects for each array elements, so now it's simply account objects. And the updates we're doing, so notice that, for example, if you want to deposit to, let's say, Steve account over here, you want to deposit that into 100. And then in our setup for the example there, we said the wrong implementation is also going to deposit the same amount to the other account. In this case, it's going to deposit wrongly to also Bill by 100. So if you think about this particular kind of change, is it a first level change? Or is it a second level change? That's really where your colleague is confused about. So this one should be considered as beyond the first level, because when I say first level, I really mean if you simply reassign this particular object to some other account. So this will be considered as the first level, right? However, what we're doing now here is we still follow through the same link of the objects. And then what we're doing is we simply change the value over here to be 100. Of course, that's definitely wrong implementation. Okay, so that's one. Okay, so that's a very quick sketch about how to answer the question there. So now let me answer that a little bit more properly. Okay, and then I will take your questions. I do see something going on the chat. I'll read it. Just give me bear with me. Okay, so for the first one here, so now I want to just say very quickly, right? If you do a shallow copy, so now that means the old imp is simply just going to point to an array over here, and then it's a shallow copy. So 1, 2, 3. So 1 here, 2 here, and also 3 here, right? We know pretty well from the previous week. And now the kind of change we're doing here is by reassigning imp2 to be Jim, right? So imp is here, imp position 2 is here. So now rather than pointing to over here, it's now pointing to just a brand new object here. Let's say Jim. That's what we're doing, right? So now if you try to compare the shallow copy against the original copy, what you will see is, so now specifically, when you say for the shallow copy over here, position 2 is still pointing to this particular original string object here. That's the pink one. And then for the post states, basically, for the imp, so now it's being reassigned to this particular Jim object. So that's the orange one. So now if you compare these two over here, so they are different. So this is where the shallow copy can be useful. If you only make the first level change by reassigning the objects, in that case, the shallow copy can catch it. That's not a problem, okay? So now, to just follow through the story here quickly, right? Let's say we still do our shallow copy over here, right? We're still doing the twin. So we got old imp, which is pointing to an array over here. So 1, 2, and 3, right? So still shallow copy. But beyond the first level, we're simply just doing reference copy over here, right? So that's still the shallow copy. So now what we're doing here is, rather than just reassigning the object as before, we are not doing this anymore. So in this version here, we'll simply append to the end of the string Okay, so imp position 2. Imp position 2 over here. So what we're doing here is follows through this particular link. So this is a string object we want to change. Rather than reassigning that, we are not doing this. Okay, what we're doing is, so now rather than this, we're going to append simply star, star, star to it. So now, why is this a limitation for shallow copy? Because if you look at the shallow copy here, let's say position 2 for the old imp, it's now pointing to this particular object here, which has not been reassigned. Whereas, so now for the imp over here, it's also pointing to the same object here. So that's why you cannot tell. So now if you simply do, for example, if you say old imp at position 2, tell that, or you can simply say, let's say do a reference copy comparison first. If you say address equal to imp at position 2, you can see this will be true already because they're referring to the same object over here, right? That's basically what we said in the lecture. Okay, so now everything that's beyond the first level, for example, if you simply change the array member over here, it cannot be caught by the shallow copy, right? That's the main lesson that we learned from the previous week's lecture materials. Okay, so now let's just address again your colleague's confusion. So now when you consider this different example, which we did about accounts, so now you really want to know whether shallow copy here, you can see we're doing old accounts.twin. So it's a shallow copy for sure. So now when you do a shallow copy, again, you're creating this particular array. So now I'll just say old accounts over here, just for simplicity, right? It's going to be a brand new array and also indices 0 and 1. But now you can see that since it's a shallow copy, twin, so now 0 is going to point to index 0 and 1 is going to point to index 1. We are not creating any new account objects, right? We're only creating a new array. So now if I try to execute this particular wrong implementation, I'm going to, not only that, I'm going to update Steve's balance to be 100. That's the correct one. However, when I also try to deposit into Bill, in that case, that'll be 100, right? So now this cannot be caught by the shallow copy for sure. It's already beyond the first level. What would be the first level change? If you simply just reassign this particular object to be something else, if this was what we did, then it could be caught by the shallow copy, but that's not what we did, so it cannot be caught, right? All right, so now if you try to do, let me do one more equality just for your colleague who asked the question. So now if you say old accounts at position 0, object comparison, right, equal here, and also b.accounts. I'll highlight that in just a moment. It will simply just be true because for now you can see all accounts at position 0 is really pointing to this particular object over here, right? It's now marking 100. It's being overwritten already, so I cannot really tell. It's actually, I cannot really keep the original value 0. And then b.accounts over here, the right-hand side, at position 0 is also pointing to the same object here. So they're simply just equal. So there's no way for me to catch the postcondition error. Okay. All right. So that's about the question the only question I saw in the Google Doc, right? That's the only one I saw. All right. Let me just read over the chat and see what you guys are thinking. Okay. So Shivan. Okay. Shivan asked a good question here. Let me rephrase it. What if we add onto the array? Would that be first or second? Shivan, that's a good question. I would say if you add to the array, that will be considered as a first level change. Okay, so now basically what you're saying is you can, for example, let me just do this here. Let me just create a new page for everybody. Okay, let me put it here. And as I also clarified before, maybe if you're really confused about either it's a first level or second level, don't worry too much. Let's not worry about the number over here. So let's just see exactly what's going to happen, and then we'll judge. Okay. Let me also copy this diagram over here. So this will be a brand new example for everybody. Okay. Let me put it here. All right. So now let's not worry about the old answer before. It may not be the case anymore. Let me just discard that. All right. What Shivan was asking was like this, okay? So let's say rather than having this, okay, what if we add onto the array? Well, so far we learned about the only way you can add onto the array is by using the force command, right? Let's write it down. So if I say imp dot force, and then let's say, for example, I want to force, let's say someone who doesn't exist just yet. Let's say Jim. And then I'm going to say here, imp dot count plus 1. Okay, let's say that. I think that's Trevor, that's what you're suggesting. Let's see. Okay. So now I would say over here, let's first of all, again, let's draw the shallow copy first, right? For shallow copy, it's going to be old imp, right? Let's say before the force, right? The shallow copy is going to be something like this. So we're going to say old imp. And then again, it's going to point to this particular array over here. You got 1, 2, and 3. So 1 is pointing to over here, and 2 is pointing to over here, and 3 is pointing to over here, right? So that's a shallow copy. And let's say we are trying to do this particular change over here. So now we are not reassigning. We are not, right? It's none of that. And also, we are not really changing any of the existing string objects. We are also not doing this, right? That's also not what we are doing. I just before I do it, I just want to tell you what we are not doing. So what we're doing here is, so imp.force. So what we're doing is we're creating just one new element over here. That's what we're doing, right? So that should be index 4, okay? Assuming that indices start with 1. And this one here simply point to a new object over here called Jim, all right? So now, let's say as far as this particular across loop is concerned, okay, as far as this is concerned. Now, anybody can tell me what's going to happen, all right? Maybe Shafan, you got priority since you asked this question, right? If the question is not clear, please let me know. I can rephrase it. Shafan, are you here? It would be true. Okay, sure, no problem. Anybody would like to offer some different opinion, or if you believe that should be true, can you tell me why it should be true? Anybody want to speak up? Yeah, Tempeh, yes, go ahead. True or false, or something else?
Something else, I guess.
You think something else. What should be that something else?
The index out of bound.
Ah, index out of bound, like a violation, right? Okay, Tempeh, good, thank you. So Shifan, maybe, I think maybe you didn't pay enough attention to the following. Notice that what we're doing here, we're saying this, right? If we have already grown the size of the array, so now in this case, what will be the index right now? What will be the count? So it will be 4, right? So what we're really doing now is, for example, how many iterations are we going to run for this particular cross loop? We're going to actually run 4 iterations, right? And then the first 3 iterations is going to be fine. Let me just do that quickly. The first iteration, we're simply comparing this string over here and this string here. They're simply the same, not a problem. The second iteration, we'll simply compare this string over here and also this string over here. That's also not a problem. The third one, similarly, we're comparing this string over here and also this string over here. Also, no problem. What about the 4th iteration, right? Because as you can see, imp.count currently is 4. So now the 4th element is over here. What about the 4th element here? Nothing. There's no. So what you will actually end up doing is, let me write it down here. In the 4th iteration, that's how we do that. In the 4th iteration, what we will get is you're going to compare imp at position 4. Tell the old imp at position 4. Apparently, this one here is going to give you basically, yeah, let's think in Java way. That's okay. That's something you're used to, like an index out of bound violation. Okay. Okay, Shifan, is that okay? Do you understand why it would be a violation here? Good, very good. So now, Shifan, I have another follow-up question for you, okay, just to test your understanding, if you don't mind. What if, let's say, rather than imp.count over here, okay, I'll put it here. What if I modify slightly? If I say old imp, dot count. So Shifan, my question for you, do you think we will still run into the index out of bound violation? No, okay. That seems to be good because now om.count, we are now using the other arrays indices, right? So now it will be only 3 iterations. However, this is not going to be correct, even though there's no index out of bound violation, because in this case, we're only comparing this, we're only comparing this and this, this and this, this and this. However, we only run 3 iterations. That means we left this out. That's not good. So your post condition is not good enough, even though it's going to be true. Okay. So now let me write down the conclusion here. So, so the green one is simply just another question here. So this will actually be true, but not good, because imp at position 4 over here is left out. Okay, so what we need to do right now is we actually need to basically expand our post condition a little bit. Okay, I'll tell you the answer. Okay, so just to save some time. Basically, you're saying that the imp and the oimp, there is certainly some possibility where the size of the array might actually have changed. In that case, you better just separately specify another post condition. So what I would say is like this. Let's say we still want to keep this guy here. Let's say we still want to keep this. Let's say this particular post condition here. Okay, let's say we still keep that. Okay, and however, I'm just going to write another one. Okay, so now the final version, let's say expanded version. So it's going to be expanded with a conjunction. Okay, I'm going to say imp.count is equal to old imp.count. And then, remember I said before in the previous Q&A, whenever we say and then, it's like a short circuit. So that means we will only evaluate this particular across loop when this particular Boolean expression is actually true, right? And then simply means right-hand side evaluated only when left-hand side is true. So that means we'll only make sure the counts for the 2 arrays are actually the same, and then we'll go ahead to really evaluate a cross loop. In that case, we wouldn't run into the index out of bound violation. Okay. All right. So guys, so I think it's a very good question by Shifan. I think that's simply something I didn't really talk about because it's a little bit more sophisticated because you're changing the size of the array. But I think it's a valid question. So now that you actually dive more into writing a complete post condition, so definitely pay attention to this example here, right? All right. Let me take a look at the chat, right, to see if there's any follow-up to this. Okay, so now, okay, let me see, Eric. Wouldn't there also be an error because in the upper end or in the upper different with? When you talk about, Eric, when you talk about upper and lower, I think we don't. Oh, I see what you mean. I see what you mean. So what Eric is suggesting is this. Even if, let's say this, even if the count of the 2 arrays are the same, let me give you one example. For example, let's say this. In principle, arrays in IPO can be created with very flexible intervals for the indices, right? It is possible to say I have array, let's say A1. And then the indices can start with maybe 1, 1, 2, 3, and 4, okay? We can have another array over here, and then we can simply rebase its indices. Let's say you can start with simply maybe 0, 1, 2, and 3, right? So now in this case, how do we really compare the 2 arrays? Let's say manually. Of course, if you simply say A1, tell the A2, let's say. If you try that, the default comparison is going to catch them because they will simply say the lower is not equal to its lower. And also the upper is not equal to its upper. In that case, it will be false right away, right? But now, how do you write this down manually? So you would say, for example, A1 the lower equals A2 the lower, and then let's say A1 the counts equals A2 that counts. Right? So these will make sure they, number one, they start with the same starting index. And number two, their number of elements in the array are the same. And then you can write some further across loop to actually go over the array without any trouble, right? And then here, this will be some maybe across loop that you can write. Okay, I'm just gonna omit the details over here, right? So Eric, I hope that answered your question, I hope, because you have some concern about the lower indices. But I think for this particular example over here, because old imp is simply just a shallow copy of the imp. So it's gonna create an array of the same lower indices. So that's not an issue here. All right. Okay, very good. Okay, no problem. Okay, so guys, I think that's about the question related to the Google Doc, and also some very good follow-up by Shivan. So now I think I'm completely open to any question you might have. So if you guys, I noticed that maybe you guys were very busy with lab 1. It's understandable, but now that it's actually due, so you may want to catch up with the progress. While you're thinking about your question, let me give you a little bit of heads up message here. So you can ask me a question if you want to, or you can wait until tomorrow, that's fine, right? The time is yours. Let me put it here. Let me give you a little bit of heads up warning over here, right? Friendly warning. For your lab number 2, okay? The official start dates for your lab number 2 should be today, right? And then I got some question there, but I'll get to it in just a moment, okay? So number 1, so lab 2 is going to require the knowledge about abstraction function. And for abstraction function, we just introduced this in week 3, just by using the sequence as the abstraction function for a lethal stack, right? That's something we did in W3. And by in W4 this week, we're actually, so in W3, we talk about a sequence. And for W4, we're going to talk about using another class called function for mathematical function. And this will be more related to what you have to do for the lab 2, because in lab 2, you actually talk about, we use a relation. That's what you got to do. But they're kind of similar, but there's some detail you have to watch out for. However, you definitely want to finish W3 first, because in W3, we definitely talk about what will really be the purpose of using the model query as an abstraction function, and how you actually can check the contract at the runtime using model. So it'll be very important to actually for you to finish your lecture series number 3. So if you haven't done that, I would highly encourage you to do it before tomorrow's Q&A, so you can still ask me questions to clarify, right? Okay, and then number 2, it will be about writing contracts. So for lab number 2, you will definitely still have to use maybe some loops and maybe some if conditional to actually finish some implementation. But conceptually, they are not as challenging as like a splay tree rotation or maybe recursion. You don't need to do that kind of stuff anymore. So it's a different focus for this particular lab number 2. For lab number 2, the main focus should be how you can write contracts using mathematical operation, especially relation, right? For lab number 2, okay? For writing contracts, you will need to also watch the lecture series number 4, okay? Over there, I talk about how you can assert, for example, set equality, right? And also how you can use the mathematical operation, okay? So you don't necessarily have to look back to your notes for 1090. You don't have to. I think for this week, in the very beginning of maybe 4B, I believe, for the lecture, I gave you some slides just for the basic concept review. That's kind of self-guided study. So maybe for next week, when you once you have gone through some slides, if you still got some problem with the basic concept, maybe speak to me or in the Q&A. Okay. Okay. Number 3 will be about the iterator pattern. This pattern is actually not so difficult. We already created all the necessary classes for you, and also all the necessary features for you to implement. But you will still have to study the lecture to learn about how it works conceptually, and especially why the design principle about information hiding and also single trace principle, etc. Why they are satisfied by using this pattern over here, right? So that's something I want to give you a heads up message. So it will be your best interest to really start with reading the lab 2 instructions today, and then you can ask me during the office hour to clarify anything for you. And then you also want to finish up your W3 lecture as soon as you can. And then you want to start with W4, right? And then, as I promised, for W5, I'm going to reduce that to 1.5 hour or less, okay, just to compensate the workload. But I think it would be nicer to really give you a slightly heavier load when your lab 2 was initially released, rather than pushing that to next week. All right. All right. Before I take any question there, I see there's one question here from Kai-Shin. Okay, let's see. What's the difference between force and put in the sequence class? You mean the array class, right? Not the sequence class. The sequence class have force and put? I don't quite think so. Maybe, unless I could be wrong. I could be wrong. Let me check it out quickly. Right. Okay, guys, let me take a look. Let me just read over your question quickly. You notice that the force has a precondition, but not the put. The precursor is yeah, I'm pretty sure you made a typo there. So whenever we talk about put and force, we talk about array, not the sequence. Okay, so I'm pretty sure you made a typo there. Okay, I don't need to look it up. Okay. Actually, both the force and the put, they have preconditions, both of them. Okay. So the question is like this. So in the array class, so if you simply want to insert to the end or insert to the middle, insert to the end or the middle. Of course, you can think about every insertion is like a to the middle, but end is just like a special case, you know, because you want to insert to the last middle points, right? So now, so whenever you say force over here, so it's going to be some index. First of all, it's going to be some value, right? Some value here. And also it's going to be some index I, right? And then let me say, so the first one is about the force. The second one is about the put. And also you got value and you got I over here, right? So now let's start with the put. The put is easier to explain. When you say put, you can think about the put is it's basically the indexing notation you're very used to in a language like a Java or C. So if I say array A dot put, let's say I want to put X into index 3, for example, right? So this will be equivalent to if I say 8 at position 3 is going to be assigned to X. They're completely equivalent, right? So now over here, the precondition for this particular index is like this. So there will be a precondition here. Require A dot, let me just say A here. A dot is valid index. And then, for example, I. Okay, more equivalently, you can say, let's say A dot lower less than or equal to I, less than or equal to A dot upper. Okay, so that's the precondition for the put. Basically, if you want to put into an array, it must be a valid index. So that's pretty much similar to your indexing notation here. So now for the force, it's a little bit trickier, okay? So I would just tell you as far as you should know for this course, okay? So for the force, you can think about, let's say this. If I got in an array over here, right? If I got in an array. If I say, let's say we got index 1, 2, 3, all the way to, let's say A dot upper. Okay, let's say this, right? That's my array over here. So now you can, if you simply call the force, okay, let's say this. When the I over here is simply between 1 and until A dot upper. The behavior is the same as if you say simply just put, because now 1 until A dot upper, they're simply just valid index. In that case, for example, if you say I want to force, let's say A dot force X into, let's say, index 3, right? If I simply do this, index 3 is actually a valid index. In that case, I'll simply insert X into here, right? It's as if you said put. On the other hand, for the put, it also allows another special case. So now, what if it's simply A dot upper plus 1? So this is something we have been seeing, right, since lab 0. So if you do that, so now it will be basically just apparently A dot upper plus 1. This is not a valid index. However, even though it's not a valid index, it's allowed by the force. In this case, you'll simply just create a slot over here, right? And then, so this will be 8 upper plus 1, and then you can insert something here. So that's basically the difference. All right, I hope that's clear. I got one question from Nora, okay? When sharing the contract with the clients, do they get to see the contract for the model query, okay? And if yes, doesn't that violate the information hiding principle? Good question. So Nora, I think your question is very relevant to week number 3, right? Let me so let me just answer your question shortly, right? When you share the contract with the clients, do they get to see the contract for the model query? Yes, indeed, because model is public, number 1, okay? Number 2, does sharing the model to the with the client violates the information hiding principle? No, it doesn't. Okay, let me tell you why. Let me recap basically the stack example quickly, and then I think in that way that'll be clearer to you. Okay. So let's say if you recall what you learned from the week number 3 lecture, we talk about a level stack, right? So let's say I got class and then stack over here. Okay. I'll just simplify that a little bit so everybody can see in a single page. And then let's say that's my class called stack. So now I'm just going to have one private section, right? So I got feature over here. And remember, we have the syntax over here. So this is so-called export status. And one equivalent to the Java private modifier would be if I simply put none over here. You can think about the none simply means I'm exporting whatever is inside this particular section over here to none of the clients that's outside. So that means it's private, right? So this is as if we said private, right? That's already covering the lecture. So I'm just reviewing quickly. And then let's say, and typically you will put anything that's to do with any design decision that's likely to change, which means it's not so stable, it's likely to change. Anything that's not so stable from the supplier side, they should be hidden as private so that any existing clients, they wouldn't be affected by that, right? That's the principle. So now, let me say for the case of the stack class, I'm just going to say, let's say implementation over here. And then for your lab number 2, you will also see we got a class called TreeDB. We got another class called LinearDB. And for both of them, you will see there are different implementation attributes. You will see that once you see the spec code for your lab 2. Okay. So for imp over here, let's say simply say array of, let's say string. Oh, actually, let's say it's generic, right? Why don't we do that? Stack of G over here, right? It's generic parameter. Also, you learned about it in week 3. And in week number 4, we will give you some challenging exercise about generics in week number 4. So once you get there, try to do the exercise and we'll discuss that next Monday. All right. So array of G over here. So now think about this particular section over here is simply just private. I'll just say red for private, right? So this part here is simply just private. Nobody can see it. All right. So now let's say this. If I got another feature section over here, okay, let's say these are the operation. Let me just use put. Let's use push for stack commands. And then if I say push over here, and then let's say I try to push maybe value v of type G, right? And let's say we have no precondition, meaning that let's say there's no capacity limits on the stack size, let's say. And now for the ensure over here, right? Okay. In your week number 3, you actually learned about complete postcondition, right? You kind of review. So let me just put an easier one just for illustration. There's another one that's going to involve the universal quantification. I'll let you study that in the lecture unless you got specific question for that. Okay. So now remember we talked about strategy number 1, strategy number 2, strategy number 3, right? We got 3 different strategies. Let's say the strategy we have currently is this. Let's say we are having strategy over here. The strategy we have right now is the top of the stack is the end of the implementation. Is imp let's say imp dot count over here. Yeah, let me just move everything a little bit to the left. Okay, so now this is strategy number one. So now if I say, let's say new top over here. Well, hopefully everybody know how to write this postcondition, right? I can simply say, assuming that the top is a query which is defined somewhere, right? The top should be the same as implementation over here at position imp.count. All right, so this is something you did actually in week number 3. Now, this would be violating the information hiding principle. Okay, let me just say that here. The fact that we are writing this particular contract over here is violating information hiding principle. Violation of the information hiding principle. Because the strategy of implementation is exposed. And more importantly, whenever you talk about the strategy of implementation, they are likely to change. So the most important detail you should really pay attention to about information hiding, right? So when we talk about information hiding, anything that's likely to change must be hidden rather than being exposed. So when you put under the postcondition that this is something that's likely to change, because if I change my strategy to be, let's say I changed from array into a linked list, and now the beginning of the list instead will be the top. In that case, I need to modify the postcondition right away. In that case, my contract wouldn't become stable anymore, would it? Right? So now, something that's likely to change must be hidden. Okay, so now, let me illustrate one more thing to you, and then I'll talk about the model. Okay, so we'll go through basically the concept again. Let's say I want to do the following change, right? So let's go on to here. Let me use a red over here. Let's say I want to do a change. Let's say number one, I want to change from array into a linked list. And number two, I want to say the top is now going to be the first element of the list. I'll just say front of the list rather than the end of the array. All right. Let's say this is the change I would like to make. So how do I make it, right? Let's see what I'm doing here, right? So rather than array, I'm going to put that into list. And the strategy is the top is going to be, rather than this, is going to be imp.first, right? The first is simply a query for the linked list class, let's say. And now, what should I change over here? So now top would be, rather than this, is now going to be imp.first. So now this will be definitely violating the single choice, First of all, you will be violating the information hiding principle, because as soon as I change my strategy of implementation from one to another, I'm actually exposing this particular detail already to my clients, because I told them previously the end of the array should be the top of the stack. But now I'm changing it, so now the client will be affected as well. So now the API is not stable for them anymore. So that's violating information hiding principle. Okay. Also, it violates the single choice principle, because whenever I change the strategy of implementation, I need to change every occurrence of whenever I mention about imp.first over here, right? If you look back to the lecture slides, I actually illustrated to you. You need to change multiple places in the stack class for the contracts when you change the implementation strategy. Okay. Hopefully, so far so good. So far, I'm just illustrating to you, if you simply just use your implementation attributes that should be hidden in your postcondition, that will be violating information hiding and single choice, right? That's what we learned in the lecture. So now, why can the model query help? So that's the question, right? So now let's talk about it once more. Okay, let me use a new page and tell you why. Okay, that's somehow also explained in the lecture, but I try to use a slightly different illustration to show you. Okay. Let me draw that very quickly again. So now let's say we got our class called stack, okay, of G. And then also feature exported to none. Okay, it's a keyword. And then the implementation here, again, let's say strategy number one, right? I'll simply say array. Array of G over here. Let me say S1 standing for strategy number one, right? The top of the stack will be the end of the array. Now, what I need to create something new. I'll put it in a different color here. What I will do is I'm going to say feature over here, and then it's going to be actually it's going to be exported to any. So it's going to be public. So I don't write anything here. Just leave it like that. Okay. You can think about this as public. That's the abstraction function we talk about. So now I'm going to say model over here, right? And in the case of the lecture, I'll simply use a sequence class for the math models. But for week number 4 lecture, I use a function. In your lab number 2, we use a relation, right? Depends on which one we want to use. Sequence of G. Let me sketch out what's going to happen here, right? So for the model over here, you're going to be do and end, right? You're going to do something over here, and more precisely what you will do will be very specific to this particular implementation, right? And just say that, right? Converts implementation array to the result sequence, right? That's what we will do, okay? And then let me just write the push over here to complete the picture. Okay, let me just make it a little bit smaller. Okay, so let's add in also our push query, right? So now let's say we got another feature over here, right? So this would be comments. And then we'll say push. Okay, and then we're going to say v of type G, right? And then we say ensure over here, right? Yeah, I'm just going to write out exactly what you saw in the lecture, right? We're going to say model tilde old model dot deep twin, right? Dot appended, right? It's a query. Appended with v over here, right? And exactly how these contracts are checked at runtime, please refer to the lecture if you haven't seen it, right? Of course, if you got specific detail, that I can also answer. But anyway, let me finish this, okay? So now, let's see the setup over here. We got implementation attribute that are private, and we got features that require us to write a complete postcondition. And in order to satisfy both information hiding principle and also single choice principle, the solution will be we want to use a public query over here called the abstraction function, which I mentioned the name in the lecture. So it's called model. And more specifically, we're going to use a sequence class in this particular example, right? And then for any particular strategy of implementation, the way you create or the way you implement this particular query might be different. However, that's okay because it's hidden. Nobody's going to see your implementation over here, right? So now let's simulate what's going to happen when you make a change. Let's say we try to do exactly the same change as before. We're going to do this particular change, right? So let me just save my writing, and I'll simply just copy this, okay? Let's say this is the change I would like to make right now. And then I want you to, I will pause a little bit. I'll give you maybe a few seconds to think about, right? So guys, this is my question here. Given the current setup, let's say I want to do a design change over here. I want to do a change. Rather than array, I'm going to write use a linked list. Rather than the top of the stack being the end of the array, I want it to be the front of the list. Let's say these are the two changes I would like to make. So now, where should I change in my current design? Where? Can you tell me exactly where? Let me start you with. Apparently, I have to change from array into linked list. And of course, now it will be strategy number 2, meaning that now the front of the list will be the top of the stack. Okay, so now, what about the remaining changes, right? Nora, you're exactly right. So now the only place, notice that I said the only place you have to change will be this particular part. How you actually convert from the implementation array, so now it will be how you convert the implementation list into the sequence. So the way you write it across loop or loop might be a little bit different. So now the most important thing to note is, do I need to change this particular guy here? Given that I actually changed my model implementation. No, I don't have to. So this particular model contract over here will always be stable for external clients, because from the client's point of view, the end of the mathematical sequence is always at the top of the stack. So now the only thing you have to make sure is if you change your implementation from one to another, in that case, you will just have to modify this only part accordingly, so that the public view for the entire sequence will still maintain consistent to the external clients. Okay, so all right, so Nora, I think that's basically a very long answer to your question, but I believe that's a reasonable explanation to you. All right, and then Tianpei, okay, ensure model why we don't call out model the deep twin to avoid reference overlap. Tianpei, I don't quite understand your question over here. So let's say this. What we're doing is we're saying alt. Okay, so we say alt model the deep twin over here, right? Notice I'm using parentheses over here. So that means what's going to happen in the pre-states is we're going to cache this particular expression over here using deep twin. You can think about it's very similar to the previous case over here. Remember when we talked about in week number 2. Over here, the correct solution should be we use deep twin for the accounts array so that any change that's beyond the first level can be caught, right, in the post condition. So a similar idea, that's why I'm using a deep twin. So I want to prevent any specific changes done by the potentially wrong implementation. They can always be feasible when I compare the pre and the post state version of the model. Okay. So guys, let me refer one thing to you, okay, in the lecture very quickly. Okay. Let me just find that. Okay, so it should be over here. Okay. In your week number 3 lecture there, so you haven't got there yet, so hopefully you'll get it very soon before tomorrow. So there is a particular illustration over there, which I did for your previous, for your lecture number 3, okay? So that one there basically is about, let me just do this. So that one there really is about how do you evaluate this particular post condition, which I just did, right? Of course, this is the final annotated version. So I'll encourage you, so if you have still got some confusion there, why don't you review just this part of the recording to see how I explain to you how we have to create model sequences in the pre and post states and then compare them in order to evaluate the post condition. That's a very important thing to understand, because for lab number 2, if you don't have that particular understanding, it will be very difficult for you to write complete contracts using mathematical relations. All right? All right, so that's good. All right, so that's about basically everything in the chat. Guys, any more questions about the lecture?
Could I
Nora, please, go ahead.
Yeah. Sorry, for my question, what I meant was for the post condition in the model query, because when you change the implementation, you have to change.
Oh, I see. I see what you mean.
Too.
Yes, sorry, I didn't really read that carefully.
I'm sorry that you had. I'm sorry.
That's okay. No, don't worry. I think it's good I explain this one more time. It's a review for everyone. No problem. No problem. Okay. Let me expand. Basically, Nora's question will fit very nice into what I have explained so far. So let me tell that quickly. What Nora was saying is like this. Let's say before the change, if I got this particular array over here, so what I should do, let me put it here, right? So that means the model itself should have a post condition. And the post condition I should really do is something like this. I would say maybe for, let me write it down, okay? Across, let's say 1 until imp dot count is I, and then all, right? So now this one will be actually easy, because I want to say the sequence will be exactly just like the array, the order, right? So now I can say maybe the imp at position I is the same as the result at position I, okay? Okay, good. So now Nora's question was like this. So now let's say if I still want to do the change over here, so now apparently because this imp over here is very specific to strategy number 1. If I change it to strategy number 2, that means I still need to modify that for sure, okay? So now that means I need to modify this particular index. You have to modify that accordingly. Okay, I'll leave the particular change to you. Does this violate information hiding? I would say this one here does violate information hiding just slightly. Although if I compare the degree of violation, it's much lighter than before. If you think about in the previous one, what we did was we actually put this particular implementation in basically almost the postcondition for every routine, right? But now we're being very controlled. We're saying that there's only one single place that we are putting the postcondition related to the implementation, which is about the model. You're right, any customer or clients, they will still see this particular one over here, but that's the only place. We try to minimize where they will see the particular implementation strategy. So I would say it's not really perfectly fine that we are not exposing anything to the client that's internal. It's true. However, I think compared with what would be otherwise the alternative, where we mention the imp in every place, is much better. It's a much better improvement, if I want to say strictly speaking. Okay, that's about information hiding. However, for single trace principle, we are not really violating it, because whenever you change your strategy over here, let's say from S1 to S2, of course, we have to modify the implementation for how the model is constructed, of course. And then it's the same model query we have to modify as well, which is to modify its postcondition. And that's the only routine that we have to modify. You can think about a single place we talk about over here is a single routine that we have to modify. Okay. So Nora, does that answer your questions, I hope?
Yes, it does. Thank you.
Very good. So I think, Nora, let me just recap. Again, it's a long answer, right? I would say if you cannot really claim that this particular solution, where we mention imp over here, is a complete satisfaction of information hiding. It's not really, but to some extent, it's very highly satisfying, not 100%. Okay, that would be the way to think about it. Okay, but it's much better than the alternative for sure. Okay, I got one question here from Jahao. Okay, so if we make the sequence private, can we avoid this? Is there any consequence? So what you're saying, Jahao, is like this. Okay, let me say hypothetically, if you want to make this rather than public, you want to make it private, right? So you're saying that I'm going to export this to none. Correct? That's what you're saying. Okay. I tell you what, as soon as you do this over here, so that means this model here is not going to be shown in the API, right? I mean the contract view. If you try the contract view for the contract view only show the public queries or commands. In that case, the model would not be shown anymore. However, it wouldn't help the situation. It wouldn't improve any further. So I would say you should really keep this as public. So basically, we're telling the clients from the contract view, they will see this particular model query, and then we are signaling to them all the contracts in my particular class for the stack, or in your case for Lab 2, the database class. We are using the model as the abstract view that's public for any potential clients who want to understand about the class. And then we're going to use the model consistently throughout for every contract in the class. So that's why it should be public, right? All right, so hopefully that answers your question. All right. All right, guys, any more? Yeah, I would say for week 3's lecture, it's not really challenging. However, I would suggest, as I said, actually in last week's announcement on Friday, I gave you some tips about preparing for your week number 3's quiz, right? I remember one of them. Oh, maybe I should talk about one of them. Since I promised I'm going to do some exercise together with you, I'll do that. Okay, so I'll do that after I say the remarks. So number 1, you should really know about how to instantiate generic parameters, which I will talk about one example together with you. Number 1. And number 2, because the very beginning of the lecture, let me tell you exactly what I meant, okay? Let me just show my browser over here. Okay. If you go to the 3B, okay, you can see over here in the beginning of the lecture over here, you can see that one there is about, to recall what you learned from the previous lecture about writing complete postcondition. And especially when we talk about implementation contract over here, we're still talking about how you can play with the indices. So now I would say to prepare, to really prepare for your quiz number 3, you may actually want to play with the indices a little bit. For example, think about a different data structure. In which case, how would you write an implementation contract differently, even though you will violate the information hiding principle, but it's still part of the coverage. Okay, so which means you got to review your week 2 lecture a little bit about deep twin about the how to play with the across notation and etc. Okay, before you attempt the quiz. That'll be my advice. Okay, so now as a promise, I'm going to talk about some example that might be slightly more complicated than what you learned in the lecture. So hopefully that will help you to get prepared for the quiz. Okay. So in your particular lecture over there, remember the one I show is simply very simple, just a stack with a single generic parameter, right? Just that. Okay. So now let me talk about something maybe slightly more complicated, slightly. Okay. So let me do the following. All right. And then we can there'll be exercise on for you right away, right? So you can take it as a quiz. So of course you wouldn't take any consequence if you answer wrong, which is good. So now let's say this. Let's say we got class. The simple example I gave to you in the announcement, like a hash table. Let me just create an artificial class. Okay, to make it more interesting. If I say class over here, okay, and then let's say my table. So let's say this. I'll simply just put B and A, assuming that B is not an existing class. Also, A is not an existing class either, right? So you can put any parameter name over here as long as it does not clash with any existing classes, okay? And then let's say this. Let's say I have feature. I'm going to omit the detail for declaring constructor, assuming that I have done that already, okay? Feature, and then I will say make. Okay, let's just say make. I think that'll be good enough for you. Let's say I simply say make, and then X like that. And then I'm going to omit the implementation here, right? Just omit. I mainly want to be consistent with how the generic parameter is used, okay? Actually, let me just declare over here. That's fine. Let me say creates make. All right. Just make it simple enough so you get my idea. So that's what I meant. You should really solve the problem in a general case, right? When you got more than one generic parameters. So now let's say in the client class, right? So now in the client context, let's say I declare two variables. I might say table number 1 and table number 2, all right? Let's say for table number 1, I put my table, let's say string, integer. For table number 2, I will also declare that to be my table. And then let's say integer Boolean. Yeah, apparently these classes are all existing classes, so that's why I can use them, right? So now I'm just gonna write something down, and then I'll ask you my question, okay? Let's say after this, I'm gonna say the following. Alan and 3 over here creates T1 the make. I don't want to make it too tricky, but you will get an idea, right? Number 1, number 2, number 3, and number 4, all right? And then over here, I can say creates over here T2 the make. Let's say I put, let's say integer, let's say true over here, okay? false, and -1, right? Just for example. So now here, let's say this is a quiz question, right? Which line or lines will compile? Okay, 1, 2, 3, 4 is a multiple choice, and the answer can be more than one, or can be none, right? Okay, let me you know what? For those of you who actually can contribute, let me not say your answer just yet. Okay, I see Chen Qi, you got some answer there. Nina got some answer there. Okay. Okay. Nora got some answer over there, and Tianpei got some answer over there. All right. Okay, anybody else want to try? Okay, you know, it's actually good for you to think about, right? I'm not going to talk about any specific answer you make, right? That's okay. I think once I explain to you, it will be quite easy, okay? I'll just wait for maybe a few more seconds. You can change your answer, that's okay, all right? All right, guys, let's now take a look. Let's see exactly what will be the reasoning process for you, all right? So now notice something here. I deliberately, I'm not sure if you noticed that, you can see I say BA over here, but I say AB over here. You know, in some ways, not really deliberately try to be tricky, because in practice, who said that you have to always say B followed by A? Not necessarily. Okay, so the order of using the generic parameter does not have to follow the order of declaring them. Absolutely not. It's completely general. You will see, even so, when you do the challenging exercise for week number 4, I think it's going to be a fun exercise for you, and then I'll talk about it next Monday. All right. Point number 1 to notice is here I say B and A, but here I'm saying A and B. Right. Number 1. Okay. So now let's say this. I want to do this as clear as possible over here. Let's say number 1. Let's say I talk about T1 over here, and that one there is simply just going to T1. String and integer, right? So now you should think about what's going to happen is, let me use blue. So that means B will be replaced by string. A will be replaced by integer. That's basically what we did in the lecture, right? So now, so that means every occurrence of B is going to be replaced by string. Every occurrence of A is going to be replaced by integer, right? So now you will know what the answer should be, right? At least for one of them. So now when I say T1.make, it should be integer followed by a string. Integer followed by a string. So number 2 should be one of the correct answer that will compile. Okay, but of course you should know why 1 wouldn't compile, right? Okay, that's the first one. But now you already know the trick already. Let me just finish that for completeness. And now let's do another one. Let's say T2 is going to be integer and Boolean, right? So what we're going to do is, let's just use paint over here. So it's going to be integer, and then it's going to be Boolean. Every occurrence of B is going to be replaced by integer. Every occurrence of A is going to be replaced by Boolean, right? So that means now we should really be expecting Boolean followed by integer, right? So that should be exactly this one over here. So the answer should be 2 and 4. All right. So actually, many of you actually got it right. Very good. All right. Yeah, so that's just another extra exercise I'd like to do with you. So now I'm just using 2 generic parameters, and then I'm just trying to say you got to be very careful when you actually do different instantiations for the generic classes. That's really the essence of using them. You will see even more challenging application when we get to week number 4 this week when you study the lecture, right? All right, very good. Let me see. Okay, that's good. Okay, guys, any more questions? Let me see this. I do see some question over here in the Google Doc. Give me one moment. Let's see this. So this one has been answered in the beginning already, all right? You explained the idea of clashing with. So I think this is a new question over here. Okay, so this is actually under the context. Okay, for generic classes. Okay, so this one here. Okay, so guys, the question is like this. I think I would just put a few minutes ago, but that's okay. So I said something about whenever you choose the generic parameter for your classes, you should not clash with existing classes. What do I mean by that? Okay, it's a good question there. Let me just tell you. What would be a violation of that? For example, let's say this. If I try to declare some generic class, let's say class over here, my class. We just used G and H before. G because G is not an existing class. H is also not an existing class. However, if I say that, if I say class, my class, here I say person. Actually, let me choose something that's definitely existing, right? Integer. And also Boolean. This one here is not legitimate. So this is not going to compile. Not compiling. Because integer and Boolean, so these are existing classes. They're classes that have been defined already. Existing classes cannot be used as names of generic parameter. Okay, makes sense? All right. However, there is another way, thing I want to show. You will find that in this week's lecture when I talk about design diagram. So hopefully that wouldn't cause confusion, right? However, let's say this, right? Let's say I have one class over here. Let me call that class. Let me just make it very explicit. Parent class, right? That's the parents, which means I want to show you inheritance. Parents over here. Let's say I got G and H. So in this case, it will be allowed because both of them do not exist. So this will be okay, right? So now this will be whatever definition you have over here. Okay. So this is the first clause over here I would like to do. And then let's say I want to have another class. It's a child class. Child. Okay, so now I have different option over here. Okay, let me show you the different options here. That'll be interesting. Okay, let's say child number 1. Okay, child number 1. If I say I want to inherit the parent class, the rule of the thumb will be if you're trying to refer to a generic class over here, you must instantiate the generic parameters, right? Let me show you what you know already. That's one way to do it, right? I want to say I want to instantiate from my parent class, and in this case, in the context of this particular child number 1, G is going to be, let's say, integer. And also H in the parent is going to be, let's say, Boolean. Okay, so this is one possibility. Okay, and then of course the rest of the child. Let me just say this is possibility number 1. Okay, I'll show you at least another 1 or 2 possibility, right? So this is possibility number 1. And notice that you're going to learn about how you can show architecture between classes. In this case, this class inherits from this particular class. Okay, so you're going to draw the red arrow over here, and then like that. Okay, so that's inheritance. All right, guys, making sense so far? Okay, so that's one way to do it. Let me show you another way, okay, which is more interesting. There might be some cases where you want to say my child class should also be generic, okay? So now how can I do that? I'll just show you one possibility here. Let me say I use maybe pink over here. Let's say I got class child number 2. let's say the child over here is going to have some generic parameter, right? Of course, you can also you can still choose G or H, but let's say I just want to choose a different name, right? Let's say I. Okay, I is a single alphabet I. It's also not an existing class. And then over here, I can say inherits. So now you can see that I still actually have to instantiate the parent, right? So now, again, I got different options. Let's say I can either choose to still say integer and Boolean. That's still fine, okay? But let's say I don't do that. I can do as follows. I can say for G, I still want to instantiate that to be integer, maybe. On the other hand, for H over here, I'm going to use I. So this will be something new to you, which I want to talk about, okay? So this is the second child class over here, and also we got inheritance. Okay, you got an error over here. Yeah, sorry about the curve over here. Pretend it's straight. Okay, so now let's say this for this particular parent for this guy here. So now, once I show you the client class for child 2, you will see exactly what I'm doing here. But you can see, let me just annotate them a little bit. This I over here is a declaration of some generic parameter. And the I over here is a use, like a usage number 1 for whatever I that should be instantiated into by some clients of child number 2. For example, let's say this. Let's say from the client side, if I say, let's say child 2 objects 1, okay, child 2 object 1. So I'll simply say it's of type, let's say child number 2. And then, sorry, I'm running out of space. Let me just make it a little bit smaller. Okay, so you can still see it. Okay, so now, so let's say if I simply say Boolean versus if I say C2, object 2, child number 2. Let's say I simply put integer, right? So now you can see the difference over here, right? Let's say, okay, again, I really want to show you the instantiation process. So maybe I should change the color over here to be blue, okay? So now think about the first one. The first one here is as if I try to instantiate the I over here to be simply just Boolean. I'll just say B here. And also this guy here will also be as if I put Boolean over here, as if. On the other hand, for the second one over here, this one here, since I put integer here, so it will be as if I put integer over here. Well, yeah, I should say integer here. And also as if I put this to be integer over here, right? So I think this guy here is something that's more common that you will see. In which case, the child class is also still generic. They have their own generic parameter. And they might use their own generic parameter to instantiate the generic parameter from their parent class, right? It's something you will actually see throughout the course. Of course, you can also incorporate that into your design later, all right? I think that there will be some insight about using generic parameters in general, which I would like to summarize maybe maybe next week, once you have tackled the challenging exercise I give to you, right? In case I keep mentioning about exercise, for those of you who may want to try right away, you can do it, okay? So if you go to the lectures page, let me just go there first. Go to week number 3, week number 4, okay? So officially it will start on Wednesday, but you may want to try as soon as you can. So the exercise is like this. So we got quite a sophisticated architecture over here. We got 1, 2, 3, 4, 5. We got 5 classes over here. We got client supplier, and also we got inheritance. In order for you to understand the architecture of this diagram over here, you will need to also study week 4's lecture about design diagram. It comes right in the beginning of the week. So I'll leave you to study that. And then in this particular case over here, you can see we got generic class G over here. We got generic class G over here. And also we got generic class G and H. We got M and N. So now figure out what's really under the block out over here, the blue one over here. So that's something I block out over here. So I would like you to figure out what they should be. That's the exercise. All right, think about it. Of course, you can potentially enter this into a computer and then try to use compiler to help you. But I would suggest this will be something I would like you to do on a piece of paper and to figure out yourself. That will definitely give you some more insight about using generics, which you didn't do, I'm pretty sure, before in the OOP course. All right. Once you grasp this idea from this course, you can definitely apply that to other OOP context. All right. It's a random question over here. Do we get solution to the labs? Yeah, once you read the lab 2 instruction, you will see there's a section about do we get solution to the labs. You will see that, all right? Okay, so let's now go on back to the Google Doc. I see there are more questions coming over here. Okay. The use of a cross keyword in the postcondition. In the previous lecture, W1. Or possibly W2. The keyword from S, I think you're talking about lab 0, basically, possibly. I think whenever you got a cross keyword, I'm saying use S rather use is rather than S, right? Okay, that's good. I can tell you that it's a legacy problem, right? So when I was creating those slides for week number 3 and week number 4, back to those days, I think that they only support the S notation, right? So when you say across, something is across, something is. So this is only supported in some newer edition of the iPhone compiler. So when I was creating those slides a few years ago, so this is not even supported. So that's why you can see in all the slides, I simply use S. I mean, in which case you will simply get a cursor object, right? However, I think some slides are also updated to use is only. So I would say which one to use is completely up to you, right? It's just a clarification. All right. Ah, good. I know this one's coming. Can I explain the syntax for G? Okay, sure. All right. So let me just maybe minimize this a little bit. Okay, good. So whenever you do generics parameter declaration, okay, let's say this over here. So we have, let's say class, let's say my class, how about that? Something you saw in your lab number 1 is about comparable. So I might say I simply got G over here and then dash greater than, right? We didn't ask you to write this, but that's something you can definitely think about later when you have to design your own classes. If I say comparable, okay, so what this means is any client class who's going to instantiate G, it must be replaced by a class that's actually comparable. So comparable, you learned about it in 2030. Comparable simply means you can define a less than relation on the object, right? So now, so let's say, that, for example, let's say, if I say in the client side, if I say object number 1, if I say my class over here, and then I need to pass something, let's say this, person. I'll talk about what person is in just a moment. And then object number 2, my class, for example, integer. And also object number 3, my class. Let me just put one more. How about string? Okay, so the person class, let's assume person is defined somewhere over here. Let's say class over here, just person. And let's say it simply got feature over here. Let's say the person only got age, for example. Let's say age of type integer. Okay. So now when you write this, right, you're saying that whatever class you put over here must be a subclass of comparable, right? So this really means instantiation must be a descendant class. So at some point after the reading week, maybe right after the reading week, we'll review all the core concept about inheritance. So we'll get more in depth about what descendant classes really are. Okay, descendant class of comparable. Okay, comparable. Actually, this also was briefly explained in the comments for your lab number 1. So hopefully you read it already. All right. So now the question is person comparable? It is not, according to our definition here. It's not. So this one is not going to compile. And then integer is definitely comparable. You can definitely say 1 is less than 2, right? So now this is okay. What about string? String will actually be okay as well, because you can definitely say, for example, 100. Let's say I think something like this. Maybe 100 is actually less than, for example, Alan, right? So the way you compare a string is by the alphabetical order. So I think numbers come before comes before the alphabet. So that's okay, right? So now, how can I make this particular line compile? Well, make the person class comparable, right? If I want to make it comparable, what I need to do is I can say inherits comparable. And pretty much like in Java, in any other OOP, the only obligation by being a subclass of comparable is you have to define the is less than relation. Right? It's going to be a Boolean, right? So you can simply say you're going to define in terms of the age between 2 persons, right? All right, so that's about this particular notation here. So now the question itself is really about something you will see in your lab, and also in many of your labs over there. So if I say over here, class, my class, here I simply say G. I think it's something like attach any, something like that. Okay, I'm glad that one of you guys actually asked about this question here. So basically, this guy here simply says any class instantiation must be a subclass of the any class, and this is actually always true because any is like any class in IFO is like the object class in Java. So any class will be okay. So I just want to tell you that the reason that we are writing this attach any, okay, is simply because it's actually for writing concurrent software, okay? In Java, you can use the Java threads. And also, if you program in C, I think they also got the threading library. But in IFO, if you want to do concurrency, so there's a particular library you have to use, in which case they require that the generic should be attached any. So for this course, you don't have to worry about. It's beyond the scope for this particular course. All right, but you should really know about whenever you see dash greater than, so that simply means any instantiation should be a subclass of or descendant class of whatever this class is. How do you do this in Java? Guys, do you know the syntax of doing this in Java? Anybody has done this before? Anybody? How do I write the equivalent of this in Java? This idea is not unique to IFO, so how would you do that in Java? Anybody? Anyone? You can write it on the chat, or you can simply just tell me. Extend, yeah. In Java, idea is exactly the same, but you will write it syntactically different. You'll say a class. You might be saying my class, right? So now rather than having square brackets, you're going to say angle brackets, and then you can say G extends. comparable. Okay, that's how you do it in Java. But it's I'm just saying conceptually, this idea is not unique to IFO. So once you learn it, it will be applicable to other OOP as well. All right, so let's see. We got about 4 minutes. Let me see. We might get more questions on the Google Doc. Let me see if I can answer them. If not, I can wait until tomorrow. Okay. Let me just find out where my web browser is. Did I close it? Okay, here. Okay, actually, guys, I answered all the new questions you gave. Okay, that's good. All right. I think that we might be able to finish maybe just 4 minutes earlier today, if you don't mind. Let me just tell you what we can expect tomorrow. Basically, I talk about, let me go back to my iPad and then before I say goodbye to you. All right. So now over here we got, today we actually also review quite many things about generics. And also that's the extra exercise I gave to you. Just hopefully that will help you learn about the subject for lab, for week number 3. And then, so that's the math models review. And then we review also about shallow copy in the very beginning. So quite many things today. So I would encourage you again to attend again tomorrow if you can. And then, so if you got any more new questions, either you can put it on the Google Doc or you can ask me tomorrow, just like today. You can put it on the chat or you can simply speak up. All right, either way is fine. Any last minute question for me before I call it a day? Everybody's okay? All right, so final remark. So I hope you will start with lab number 2 very soon, because lab 2 does require some understanding about inheritance, polymorphism, and dynamic binding, which we also explain in the problem section there. You want to go over that, and also you will get a lot of chance to write about complete postcondition. That's something that will take some thinking to actually finish. So you may want to start as early as possible. All right.
Mr. Jackie, are we going to get our feedback and our grade for our lab 0 and for lab 1 afterward?
Yeah, the feedback, yes, indeed. So the question was, are you going to get grades and feedback for your labs in general? For sure, you will. Currently, I'm still just waiting for a few submissions from your colleagues, which just for some extended submission, they got granted for legitimate reason. So I'm going to wait for their submission just for maybe 1 or 2 days. And then as soon as they have submitted their work, I'm going to start grading right away. And then I'll be in touch with you just about lab 0 and lab 1. And the way you can check your feedback is just the same as before. Remember, when you check your check result, you'll say feedback 3311, like a lab 0 or lab 1, right? You'll do the same thing. So once the grading is done, you can actually look up your feedback and see if you got any marks deducted because maybe of some failing test. And then for the marks, I will use ePost to tell you the result. So it's a little bit different from the E-class. All right. Hey guys, any more questions? Another question here, how much of week number 4 lecture will be required for lab 2? I would say every detail I mentioned in week 4's lecture will be relevant to lab number 2. Yes, that's why I want to just give you everything that's required for lab 4 just this week. So you can finish that as soon as you can. So that will also help you complete lab 4. If I try to leave some stuff until next week, it might be too late for you to actually complete your lab 2. That's why, that's my thinking, right? So what do you mean about week number? Yeah. So you in principle, as I explained in the syllabus section there, in principle, I will definitely release the lecture no later than Wednesday. But I'll try to, in practice, I'll try to give you the lecture to you maybe earlier. So you can definitely start with a week 4 lecture already if you wish today. All right. Okay, guys. Actually, thank you so much for coming, and then I will see you hopefully tomorrow. All right. Have a good night.
Bye-bye, sir.
Bye-bye. Take care.
Bye, Professor.
Bye-bye. Take care.